For his sensational contributions to the fields of material science, Michio Kaku has, as a general rule, certified that the James Webb Space Telescope JWST has observed 6 colossal structures that scientists thought couldn't exist. These observations have the potential to open up new viewpoints on how we could interpret the universe. The revelation is both engaging and moderately testing existing theories about the new formation and evolution of galaxies. It is, therefore, important to keep an eye on these updates. The statement by such a recognized expert highlights the significance of these findings. Michio Kaku is a remarkable figure in the scientific field, a physicist of American and Japanese heritage. He is regarded as a specialist in both traditional scientific material science and quantum mechanics. Unlike some other more conservative and controversial scientists, Kaku has been open to the mysterious findings of the JWST mission. His eagerness to embrace new discoveries and share them with the public shows his commitment to advancing our understanding of how we could interpret the universe. We are pleased that this renowned scientist has chosen to break his silence and openly share what can no longer be denied. The energy and almost captivating tone of the famous physicist are clear in his remarks about the revelation made by the James Webb Space Telescope, showing that this discovery has sparked his interest. Join us as we explore the implications of Michio Kaku's disclosure of these 6 enormous structures. Kaku is a scientist who has always been open to considering new theories. Throughout his life, he has shown a willingness to entertain ideas that challenge the status quo. He recognizes that Einstein's theories of relativity and Newton's laws, while pivotal, fall short in explaining the full complexity of the universe. Kaku appreciates that the revelations of the new telescope could potentially propel the field of cosmology forward, although many of his peers are still hesitant to embrace this view. This reluctance has caused concern and unease among Big Bang theorists and critics of quantum mechanics. However, this only prompts laughter from Kaku. The JWST has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed only a brief time after the Big Bang. The team of astronomers who made the discovery has named these bright, magnificent galaxies universe breakers, as, when confirmed, they would undoubtedly change our understanding of the universe. The implications of these discoveries are vast, suggesting that the universe's early years were far more dynamic and complex than previously thought. One thing is clear. The theory of how things came to be no longer fits. The theory that the universe was violent after the initial event, and that the first solid objects took a vast number of years to form, eventually creating light, no longer seems sufficient. The development of complex structures like galaxies was assumed to occur much later. Some of the newly discovered galaxies are larger than the Milky Way, and their immense beauty suggests they were likely forming many new stars every year, while our galaxy produces stars sporadically. The precise moment these early galaxies formed is still a mystery, but what is evident is that initially, there might have been only single stars or groups of stars that later merged to form larger structures. Over time, small, dwarf galaxies merged into larger, more massive galaxies. This raises a question. Is the universe older than previously recognized, or did complex cosmic structures form much earlier than thought? This presents a challenge for conventional science, which still struggles with this model. Some aspects of material science have firmly rejected these findings, questioning the accuracy of the age estimates. Kaku is aware of this and had this to say: "There are many models of outdated and misleading theories that persist due to the influence of certain scientists. Many of these theories were likely disproven when basic research revealed their flaws. Thus, the strength in any science, especially physics, lies with the experimenters who keep researchers grounded and cautious. In truth, on Earth, we know very little about the true origins of the universe." This statement from Kaku emphasizes the importance of continuous experimentation and validation in the scientific process. The theory of how things came to be was first outlined in 1927 based on observations of the universe's expansion, This data led to the conclusion that the universe began from a specific point and has been expanding ever since. At the time, it was difficult for people, including scientists, to imagine a universe with both a beginning and an end. The idea of a universe that had always existed and was infinitely expanding was beyond human imagination. Even today, scientists still struggle to fully grasp it. Nonetheless, it is crucial to consider these possibilities, even if these new discoveries do not align with what experts have believed for decades about the origin of the universe. Science has repeatedly shown that reevaluation and openness to new ideas are essential components of the scientific process, particularly when confirming certain theories and observations. When Einstein was young, it was once believed that stars and planets were fixed in place in the universe, and that these specific arrangements occupied a defined space. Today, we know that everything in the universe is in motion. Planets orbit stars. Stars move within galaxies at speeds of several kilometers per second, and entire galaxies rapidly move through the universe, whose fate we still cannot predict. This revolutionary perception of the universe challenges long-held beliefs and highlights the need for ongoing inquiry and change in scientific thinking. Today, scientists are challenged to identify unusual phenomena and understand that theories are not definitive until they have been fully tested or confirmed through observation. The Big Bang Theory emerged from the realization that galaxies are moving away from each other, and this distance correlates with their separation from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding over time. Phenomena such as cosmic background radiation and the redshift of light from distant galaxies, along with other cosmological patterns, seem to support this theory. However, it is important to remember that in the past, people who believed the Earth was flat and that the Sun orbited us also had observational evidence for their beliefs, until new events or technological advancements provided a clearer picture. We are now in a similar situation. Scientists expected the new James Webb Space Telescope to confirm questions associated with the Big Bang, but instead, they have encountered these 6 astronomical structures that seem to defy expectations. This demonstrates that science is always evolving, and researchers must remain open to new discoveries and reassess existing theories based on available evidence. The groundbreaking discoveries have challenged current understanding and prompted a reevaluation of long-standing cosmological theories. Researchers use redshift as a tool to measure various aspects in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as light sources and observers move relative to each other. To understand this, imagine stopping and hearing the sound of a car approaching. As the car gets closer, the sound of the engine increases in pitch. Conversely, when the car moves away, the sound decreases. The same is true for light. When a light source, such as a distant star, moves toward us, the light shifts to bluer wavelengths. When it moves away, it shifts to redder wavelengths. This phenomenon is called redshift, and physicists have translated redshift values into rates and distances for measuring cosmic distances. However, it is crucial to note that even a small error in these measurements can have significant consequences. The methods used for these measurements are now under review. The recent discoveries related to our universe require careful consideration of whether they are based on potential redshift errors, or whether some researchers are rejecting current facts. This is a question that requires thorough examination and a careful study of the data and methodologies used in the research. The continuous evaluation and reassessment of research methods highlight the growing importance of critical inquiry in science. Thank you for watching the video. As always, we encourage you to leave your comments below. If you enjoyed the video, make sure to hit the like button, share it to reach a wider audience, and subscribe to our channel so you don't miss more content like this. Thank you for watching, and see you in the next one. This call to action enables viewers to engage with the content, fostering a community of curious minds eager to explore and understand the latest scientific discussions. The study of our universe, with its vast distances and complex celestial bodies, continues to challenge scientists in new and exciting ways. As technology advances, tools like the James Webb Space Telescope provide us with unprecedented views of the cosmos, revealing phenomena that were once thought impossible or beyond our reach. These discoveries force us to reconsider long-standing models of the universe, requiring scientists to rethink the origins, evolution, and ultimate fate of the cosmos. Kaku, with his deep understanding of physics and his open-minded approach, exemplifies the spirit of scientific inquiry. He encourages his peers, and us as the public, to remain open to novel ideas and theories, no matter how they challenge the status quo. The universe is vast and complex, and every new piece of information adds to the puzzle. The revelations from the JWST may not only help answer old questions, but may also spark new inquiries that push the boundaries of our understanding even further. As we continue to explore the universe, these new discoveries highlight the importance of scientific collaboration and the willingness to adapt to new evidence. They also remind us that science is a dynamic process, constantly evolving as we learn more about the world around us. The universe, with all its mysteries and wonders, is a source of endless fascination. The breakthroughs of today could shape the scientific paradigms of tomorrow. Once again, thank you for engaging with this topic. The discussion surrounding these discoveries is only beginning, and we look forward to further explorations of the findings and their implications for our understanding of the universe. Keep questioning, keep seeking, and keep exploring.